Welcome to this explainer. Today, we're jumping right into the wild, decades-long roller coaster ride of artificial intelligence. And I mean it really has been a roller coaster. It's this fascinating, kind of crazy history filled with these absolutely grand promises, crushing winters where funding literally just evaporated, and then, these monumental algorithmic breakthroughs that have totally reshaped the world we live in. Ultimately, this is a story about human ambition, hitting a wall with technological limits, and our absolutely relentless pursuit to build a machine that can actually think.
So, let's start with a big question. How exactly did we go from those giant, clunky, room-sized calculators in the 1940s, the ones that basically just crunched math for military trajectories, to the AI we're all using today? AI that can hold a perfectly fluid conversation, write poetry, or even help diagnose diseases? It's honestly an incredible 70-year evolution. Now, to really wrap our heads around the sheer scale of where we're at right now, just take a look at this number. $500 billion. That is the massive investment plan for AI infrastructure in the U.S. alone by 2029. I mean, we are living in an era of completely unprecedented AI adoption. But, to understand why this massive explosion is happening right now, today, we've got to hit rewind and see exactly how we got here.
Okay, let's rewind all the way back to the very beginning, the early dream of thinking machines. Back in the mid-20th century, there was this absolutely boundless optimism about creating thinking machines and, creating them soon. The bedrock for all of this was laid in 1950 by the brilliant British mathematician Alan Turing. He posed this profoundly disruptive question: can machines think? And this simple question completely set the stage for the famous Turing test. Basically, he proposed that if a machine could somehow trick a human into thinking it was human during a text-based conversation, well, we should probably consider it intelligent.
And things moved pretty fast from there. Just a few years after Turing's paper, in the summer of 1956, researchers got together at the Dartmouth workshop and officially coined the term we all use today: artificial intelligence. Early progress seemed, honestly, incredibly fast. Fast forward to 1966, and MIT developed ELIZA, which is pretty widely considered the very first chatbot. It used this really simple pattern matching to mimic a psychotherapist, but at the time, people were absolutely astonished by it.
But, as you might guess, that honeymoon phase didn't last forever. The field was about to plunge straight into the bitter AI winters.
Those dizzying peaks of early optimism, they're pretty quickly collided with some incredibly harsh technological realities. There was just this massive gap between the initial promises and what the tech could actually do. I mean, the promise back in the 1960s was literally that machines would be doing any human work within 20 years. The reality? Well, early systems were completely paralyzed with what's called the combinatorial explosion. Basically, the math just got way too complex for the computers they had back then. And this led to some frankly hilarious but grotesque errors. Like there was an early translation program that tried to translate, "the spirit is willing, but the flesh is weak." And it actually spit out, "the vodka is good, but the meat is rotten." Seriously.
The AI researcher Hans Moravec really hit the nail on the head in 1976 when he diagnosed the era's biggest limitation. He explained that artificial intelligence needs computing power in the exact same way that an aircraft needs horsepower. Trying to achieve true AI back in the 70s with those early computers, it was literally like trying to fly a jumbo jet using the engine of a lawnmower. The theoretical ideas were mostly all there, but the raw computational horsepower they needed was just completely missing. And that profound lack of real-world progress led to some devastating funding freezes across the globe. A huge catalyst for this was the 1973 Lighthole report over in the UK, which just heavily criticized the entire field for utterly failing to achieve its quote-unquote grandiose objectives. As a result, governments and defense agencies totally pulled their investments. This caused an AI winter, where research pretty much stalled out and enthusiasm just vanished overnight. The field would actually go through a second, very similar winter in the late 1980s when the market for specialized expert systems completely collapsed.
Okay, so let's fast forward a bit. We're getting out of the cold and moving into the deep learning revolution.
So skipping past those brutal winters and into the 2010s, exponential computing growth finally started to vindicate all those decades of struggling research. But here's the thing: these algorithms desperately needed fuel. Which brings us to this really staggering number, 14 million. That is the exact number of hand-annotated images inside the ImageNet database, which was spearheaded by the brilliant researcher Fei-Fei Li. Now, artificial neural networks had actually been around since the 1940s, but ImageNet, it finally provided the massive structured scale of data that was absolutely necessary to actually train them. It was a real game changer.
And this data sparked a massive paradigm shift in 2012. Over at the annual ImageNet Visual Recognition Challenge, a deep neural network called AlexNet came in and completely destroyed the competition. I mean, it won by a staggering 9.8 percentage point margin over the runner-up. It was an absolute watershed moment in computer science. All of a sudden, deep learning was practical, it was incredibly powerful, and it triggered this massive global resurgence in AI funding. The winter was officially over.
Which leads us to the next massive leap, all thanks to a paper with a very catchy title, Attention is All You Need.
So in 2017, we saw another monumental leap forward with a landmark research paper from a team at Google simply titled Attention is All You Need. The core idea of this paper was a concept called self-attention. Now before this, AI essentially read text a lot like you or I do, sequentially, just going word by word. But for a computer, that's incredibly slow, and older models would actually forget the earlier context by the time they reach the end of a long sentence. Self-attention completely fixed this. It allowed models to process entire sequences of words in parallel, analyzing the mathematical relationships between all the words simultaneously. This fundamentally changed the entire trajectory of natural language processing forever.
Okay, so how do these transformer models actually work? Let's break it down without getting bogged down in all the heavy math. First off, the input text gets broken down into small little chunks, called tokens. Then, instead of reading those tokens sequentially left to right, the self-attention mechanism dynamically analyzes the relationships between all those tokens in parallel, all at once. Finally, it uses multiple attention heads to capture diverse contexts simultaneously. So it's basically mapping out complex relationships instantly, which allows the AI to truly understand the deep, messy nuances of human language.
And that specific breakthrough brings us straight out of history and right into the modern AI boom.
That massive architectural breakthrough is what launched us directly into our current world of large language models. In fact, that single 2017 transformer architecture is the literal T in ChatGPT, Generative Pre-trained Transformer. That one single paper directly gave rise to the incredibly powerful models we're all using today. We're talking OpenAI's GPT series, Google's Gemini, Anthropic's Claude. The entire tech industry pivoted based on this one single innovation. It's wild to think about.
Just look at how incredibly far this technology has come from those early, bitter winters of total disappointment. I mean, when ChatGPT launched, it reached 100 million users in just 2 months. That is the fastest consumer software adoption in history, period. These modern models can now write incredibly complex software code, generate highly creative content, and researchers are even evaluating them for early signs of AGI, or artificial general intelligence. The impact here is so profound that the foundational work in neural networks just earned pioneers like Geoffrey Hinton and Demis Hassabis the 2024 Nobel Prizes in Physics and Chemistry. It's just astonishing.
But as we wrap up this explainer, looking back at this long history of staggering booms and busts, we really have to look forward. And I want to leave you to ponder this incredibly provocative question. This is taken directly from a famous open letter that was signed by thousands of leading AI researchers, and they asked, should we develop non-human minds that might eventually outnumber, outsmart, obsolete, and replace us? So what do you think? Will our current seemingly endless summer of AI innovation lead to some sort of technological utopia, or are we actually risking a fundamental loss of human control? Understanding this history really helps us see the stakes, but the future? Well, that's still unwritten. Thanks for exploring the rollercoaster history of AI with me today.